In this section, we'll discuss a second question on Newton's method. And here, as you can see, we are given two graphs and an intersecting point, and we are supposed to find out where or exactly for what x value here is this intersection occurring. What's the value here? So that's what we're supposed to find out. And we have to keep approximating for this value of x until two successive approximations differs by less than 0.01. So what do we do for this particular kind of question is that we first find out our function. So we have got two functions here, f of x and g of x. Let's say our function is h of x, which will be f of x minus g of x. So our f of x here is 2x plus 1 minus g of x, which is root x plus 4. So that's the function that we are actually supposed to work with, h of x. And also we know for Newton's method we need the derivative, the first derivative of this function. So to find out the derivative of the function, we'll rewrite the h of x in a way that is easier for us to derive it. So we would write this one here as 2x plus 1 minus x plus 4 to the power half. So square root is nothing but to the power half. Now to find out the first derivative of this function, we can find it out easy. So 2x, it would be just 2, and when you have a constant plus 1, that would be turned into 0, so we don't write that. And then we have minus, half is multiplied to the front, and then we have here x plus 4, half minus 1, which is minus 1/2. Alright, so that would be the first derivative of the function of us. So this is our function. This is our derivative of the function. And now what we need next is our initial value. These are the things that we need to start working using the Newton's method formula. So the initial value, let's call it as x1, would be, let's catch somewhere close to this value of x, somewhere close by. So I would just say 1 is very close to this x, so I would start with initial value x1 as 1 here. So I'll just take it as 1. Now if we start working, so let's write here, we have n, we have here n, and then we have xn, and then we have f of xn. So the function was for us, let's rewrite the function we have is 2x plus 1 minus square root of x plus 4. So that's our function. And then here we'll find out the derivative of the function, which was, let's see it again. So here we have 2 minus half x plus 4 raised to the power minus half. So we have 2 minus half. I would just write the half as 0.5 in bracket x plus 4 raised to the power minus half, so minus 0.5. That makes it easy to calculate. And then here we'll have the formula, that's xn plus 1 plus the Newton's formula is equal to xn minus f of xn divided by f dash xn. Okay, so we have got all our table content. Now let's start progressing. So for n is equal to 1, x1 we just took it as 1 here. So x1, the initial value, we considered here as 1. We just took this particular one here to make it easier for us to arrive at the intersection point. So now f of xn, so f of x1. So if we put 1 in this function, we'll get 2 times 1 is 2 plus 1 is 3, 3 minus 1 plus 4 is 5, so 3 minus root 5 will give us 0.7639. And if we put 1 into the first derivative of the function, we'll get here 1.7764. And then if we use the Newton's method formula now, using the values here, we'll get the value as 0.57. So for the first time, maybe let me write it down here. So it would be x2 is equal to x1, that's 1, minus f of xn, that's 0.7639, divided by 1.7764, that is equal to 0.57. Okay, now for the second one, the x2 now is 0.57, and f of xn, that is in the function now, if we put the value as 0.57, we'll get here as 0.0022, and putting the same one inside the derivative, we'll get here at 1.7661, and then the value of x3 will be, using the formula, 0.5687. Now, what we are supposed to check is successive approximations. If the difference between them, that is, if you subtract them, is the value less than 0.001 here, right? So if you subtract 0.5687 minus 0.57, what you get here is the value as 0.003, so that's not less than 0.001, right? That's more than that, so still it's not satisfied, so we have to do more steps. So let's go ahead and do one more step now, to the third step, and here the value of x3 is 0.5687, and then when we put this inside the function, what we get here is 0, and here we'll get 1.7661, and then here we'll get x4 as 0.5687. So now if you again subtract successive ones, we get here 0, which is less than 0.001. True, so we can stop here, and our root of the function, or the intersection point, is here. How do we write it? So the intersection of the two graphs, so we can say the intersection point, therefore the intersection point is at x is equal to 0.5687. So that's the point where both the graphs are intersecting.